Good morning, friends. In this video, we are going to discuss the Boolean expression simplification using Karnaugh map. So, in this Karnaugh map, we have different steps for simplifying the given Boolean expression. So, the steps for that is what are the steps we need to do for simplify the given Boolean expression using K-map, and what are the steps that is not possible to do in this K-map. So once we understand this concept, then the remaining things will be very simple for you people. So first one, the grouping of cells. Actually, in that K-map is nothing but actually that is your systematic method to simplify the given Boolean expression. And in this technique, the information contained in a truth table are available in POS, that is product of sum, or SOP, sum of product form, is represented on the K-map. And also, what are the steps for grouping of this K-map cells means? So first one, so the grouping of cells in powers of 2, like 2, 4, 8, that can be possible. And also, the steps for converting SOP to the POS and POS to the SOP. That is your standard. That is, if you have a given question is having the standard SOP or POS, then only it is possible to simplify the given Boolean expression using K-map. Otherwise, we need to do the steps for this conversion of SOP or POS into the standard form. Then only we go for this K-map simplification. And the grouping of horizontal or vertical even powers of cell and grouping of all corners of cells is also possible. Whenever your all corners of a cell, like if you have a function, say for an example, if you have a function like this, then we can group it as a quad group. This is called quad group. Quad is nothing but a combination of 4 cells. It is called quad. So this is possible. And what are all the steps that is not possible in that K-map simplification means? First one, grouping of one cell is not possible, and also odd numbers of cells and grouping of 6 cells. Odd numbers of cells means, if say for an example, here you have 1, 1, 1. So this grouping is not possible. So this is a wrong method of grouping. So here the grouping is not possible. That is, a grouping of 3 cells is not possible. So odd, similarly, grouping of 5 or 7 cells are also not possible. And also the grouping of all don't care conditions. Okay. So next we discuss about the grouping of all don't care conditions. Okay, that is also not possible in this case of Karnaugh map. And now one more important thing, that is your diagonal grouping of min terms or max terms. That is also not possible in that Karnaugh map simplification. And now directly straight away we need to go for our K-map simplification. So before going to this, so first let me know that how to allot the cell numbers for a 3 variable K-map. So if you have a 3 variable K-map, then the total number of cells in that 3 variable K-map is 8. So the allotment of variables for this cell numbers is given here. That is your 0, 0, 0, 1, 1, 1, and 1, 0. So here the important thing is, here see to that your 0, 0, 0, 1, and afterwards 1, 1 we are using in it. Instead of 1, 0, we are using 1, 1. The reason is, in Boolean, that is your K-map simplification, at a time only one bit is allowed to vary. So that's why here after the 0, 1, we are using 1, 1. and then 1 0. Okay, yes. And here we have to allot the variable for this a is a 0 and 1. Okay, yes. So this is a way we need to specify the variables in case of a 3 variable K map. So if you have a 3 variable K map, the total number of cells are 8. And also the how to allot the cell numbers means, so here 0 0 0 is 1 and 0 0 1, already we know that your min terms is a 1, and here 0 1 1 means your min term is a 3, and here 0 1 0 means your min term value is a 2. And similarly here 4 1 0 0 4, and here 1 0 1, that is your 5, and here 7, and here 6. So this is a way we need to allot the cell numbers for a 3 variable K map. So now we have to solve the 3 variable K map with one simplification, and also the 3 variable K map. So first let me know that is whether the first we will check that whether the given question is in a standard SOP or POS. Okay, yes. So now your question is, so this is your question number 1. Obtain the minimized SOP. Obtained the minimum SOP for the given function f is equivalent to summation of m 0, 2, 3, 4, 5, 6. So this is your given question. So see to that. So for that question, the first step is, so see to that. So for this given question, the first step is uh, we need to check whether our question is having in the form of min terms or max terms. So here, so from this summation of m itself, we know that, so this is your min term. So now we have to represent the min term as a 1. Okay, and min term is a 1 with the corresponding cell. Okay, so see to that here min term is a 0, so that 0 is represented here, min term is a 1. Okay, and similarly here 2 and 3 and 4, 5, and then 6. So these are all the min terms that is given in your question. And next step is we need to group this min term. So how will you do the grouping means? So the first step, the foremost important thing in grouping is we have to group as maximum. Okay, so first check this, since it is a 8 variable K, 3 variable K map. So we have to first try to grouping of any 4 cells are possible. Okay, so yes, so here see to that. So see to that here. So this grouping of 4 cells is possible here. That is your consider, this is your group number 1. So now G1 is nothing but write down the corresponding min terms for this group. Okay, and also corresponding cell numbers. So group 1 consists of your cell numbers 0 to 4 6, and its corresponding min terms are and its corresponding min terms are given by 0 0 0 is nothing but a bar, b bar, c bar, and then 2 is nothing but your a bar, b, c bar, and 4 is nothing but a, b bar, c bar, and then 6 is nothing but your a, B, C bar. So these are all the corresponding min terms for the given expression. So see to that out of this 4 expression, so we should take only the common terms in this 4 expressions. So see to that in this 4 expression, your C bar is a common. So common term is a C bar. We need to write it here. Okay. Yes. Similarly, we go for the next grouping. So see to that. So next grouping is here. That is your quad group is already completed. Grouping is completed. And next here is called your pairing. Okay, so this is called your group number 2. That is called your pairing of 2 cells. Okay, so that is your pairing of 2 cells is called your G2. So the corresponding cell number for this one is 4 and 5, and the corresponding min terms for this expression is your grouping of 4 and 5. So see to that here A, and here that is your grouping of 4. Okay, so A, B bar, C bar, and then A, B bar, C. Okay, so this is your respective min terms for this group 4 and 5. Now again we need to take only the common term, common min terms in this 2 cells. So the common min terms in this 2 cells are given by A, B bar. Okay, so this is your common min term. And next we go for one more grouping, because try to group as it that is try to group the maximum, okay, as it is possible. So here that is no ones is left free. Okay, so next we go for the next grouping. So see to that here. So your grouping, so consider this is your group number 3. So now G3 is a combination of cells 2 and 3. So the corresponding min terms for this expression is A bar, B, C, and then A bar, B, C bar. So this is a corresponding min terms for this expression. Okay, so your A bar, B, C, and then A bar, B, C. So here the common term is A bar, B. Okay, so your next step for this minimized. So now all the grouping is carried out. Okay, completed. No ones is left as a free here. So see to that here. Yes. So now your minimized SOP. So now the minimized SOP for this given expression is write down the corresponding min terms for each and every group. C bar plus A, B bar plus A bar, B. So this is your corresponding min terms for the given expression, that is summation of M 0 to 2, 0, 2, 3, 4, 5, 6. Thank you.